Okay. Now that you know what the theoretical yield is, when you're given a problem and they ask you to calculate the percent yield, they will have to give you one of these, and they typically will give you the actual yield. They say, we actually made this much in the lab. Then you have to calculate this theoretical yield, and then you can calculate the percent yield after that, okay? So let's take a look at the last set of practice problems, and I will give you an example, okay? I believe I gave you some practice. Did I give you a packet with some practice problems in it? Some limiting reactant? Okay, so you've got practice with keys if you need it. Just letting you know. Let's look here at this last part. So let's do number 2, okay? Number 2 says you've got 15.2 grams of barium bromide reacting with sodium phosphate. This is not a limiting reactant problem, okay? You're forming 9.5 grams of precipitate. What's the percent yield? Okay, so barium bromide is BaBr2, and it's combining with Na3PO4. Double replacement reaction, you're going to form NaBr and Ba3PO4 and this is my precipitate. And then to balance it, you're going to need, I think, a 6 here, a 2, and then a 3. There we go. Okay. So what they did was they said, you've got 15.2 grams of barium bromide. We have an excess of the sodium phosphate, which means we will not run out of it. And then we're forming 9.5 grams of barium phosphate. This number right here is the actual yield. So that means they did the experiment, they made that much. That means you have to calculate the theoretical yield of barium phosphate so that you can then calculate the percent yield. Okay, so you would take your 15.2 grams of barium bromide, convert it to moles by dividing by the molar mass. What's barium? I rarely use it.
137.33.
It's that big, huh? 137.33 plus 2 times 79.9. All right, so this is 297.13. There, grams. And then you've got a 3 in front of here. And then you've got a 1 in front of here. And based upon the unit that they gave you for the actual yield, since they gave you grams, that's how I know I've got to convert all the way over to grams here. Okay, so this is going to be 137.33 times 3 plus 2 times, what's P? 30.97 plus 8 times 16. Why is it not coming out? All right, that's a huge number. I got 601.93. That's a huge molar mass, but okay. 15.2 divided by this, divided by 3, times 601.93. All right, this is going to be 10.3 grams. That's my theoretical yield, okay? So that's how much I should make if I were to actually do this. And your percent yield would be the actual divided by the theoretical times 100. So this is going to be 9.5 divided by 10.3. Grams will cancel. Times 100. Your unit here will be percent. So 9.5 divided by 10.3 is 92%. And you're done. Okay. You might get a really short percent yield problem where you're given both actual and theoretical and you just divide it. Or you might get one like this. Or you might get one that has a limiting reactant component to it. Does that make sense? Okay. So I'll open up this homework and that's it. Okay. Any questions on this? Yeah.
If you get an equation where there are two reactants given, do you use the bigger product in this?
No. No. If you have two reactants given as limiting reactant, pick the least amount of product that was produced. That's your theoretical. Okay?